Hello, my name is Trần Đức Thuận, and in this video I will talk about my robot design and build project. I started by creating a 2D sketch of the chassis profile using the sketch tool. First, I draw a chassis. After deciding the dimensions, I use the extrude tool to turn the sketches into 3D parts. I also apply fillet to round the sharp corners, making the chassis look lean and safe. This is the top view of my chassis. The large flat platform provides enough space for the Romeo and the battery holder. Keeping these components on the top layer make wiring easier and allow convenient access during programming and maintenance. From the front view, we can see the vertical front plate. In this plate increases the rigidity of the chassis and also provides a mounting position of the brake ball. It helps organize the electronic connections and makes future modification easier. This is the right view of the car. The chassis uses a two-level structure. The lower level is mainly used for the motors and the ball caster wheel, while the upper level supports the Romeo and the battery holder. This layout separates the mechanical part from the electronic components, making assembly much simpler. In the bottom view, there is enough ground clearance for the car to move smoothly without the chassis touching the floor. The DC motors are placed on each side of the chassis. This position provides equal driving force to both wheels, helping the car move in a straight line. The battery holder is positioned in the center close to the rear of the chassis. Because the batteries are one of the heavy components, I place the battery here to improve the car's balance and distribute the weight more evenly. As a result, the car is more stable and less likely to drift while moving forward. The Romeo is mounted on the upper platform. This position makes programming, debugging, and cable connections much easier. The brake ball is installed on the front of the robot. This location allows quick access when testing circuits or adding new electronic components during development. The ball caster wheel is mounted at the rear of the chassis. Together with the two right wheels, it creates a stable 3-point support. This design helps balance the car to move smoothly. That is the overall design of my car in Fusion 360. After completing the CAD model and confirm the component layout, I proceeded to manufacture the chassis using 3D printer. In the next session, I will explain the manufacturing and assembly process. After finishing the CAD model, I manufactured the chassis using a 3D printer. When designing the chassis, we also consider how easy it would be to print. I also gave the chassis flat bottom surface so it can be printed without too many complex support structure. This improves print quality. After printing, I only needed to drill a few holes a little bit to make the screws fit. This is a common step in 3D printing. The car was designed to simplify the assembly process. Each electronic component has a predefined mounting location on the chassis. Cable routing was also considered during the design process. The open layout provides enough space for the motor wires, reducing wire interference and making the final assembly much cleaner. This connection is based on the circuit diagram teacher provided. I also consider maintainability when designing the car. Components that are often used or may need maintenance, such as the Arduino and the battery, are easy to access after assembly. The motors are mounted with screws so they can be replaced quickly if they are damaged. Finally, the open chassis make it much easier to check the wiring or troubleshoot any problem during testing. After completing the hardware assembly, the control program was developed in Arduino IDE. The code controls both DC motors through the motor driver to achieve straight line movement. During testing, several parameters such as motor speed were adjusted to improve the robot movement accuracy. After program was completed, it was uploaded to the Arduino through a USB connection. After uploading, the car was tested several times to verify that all hardware and software components were working correctly. Finally, the completed car was tested. The car successfully moved forward in a straight line according to the project requirements. I tested the car several times to make sure it worked consistently and to find the system.